Okay, I've decided to expand my description of why the macroscope and the microscope are not like two different realms or different physics, as if quantum physics suddenly says, "Oh, hey, it's an inch. Forget it. I don't count. You better use that Newtonian mechanics. It's totally correct now." No, it's just an approximation we use because it's easier. Well, don't you get about that? We don't have infinite ability. We use Newtonian mechanics because it's easier and it's good enough to get to the moon. Who needs, good enough for a particle accelerator? Unless you're building a particle accelerator, in which case the fact that you need the tough stuff should tell you. You see, you can calculate the path to the moon in quantum physics. It's, doable. And if you make approximations as you do, you get Newtonian mechanics. So anyway, this is about reductionism. So let's start with a little bit of Fineman. You guys should all watch a lot more Fineman. And here we go.
I have a friend who's an artist, and he's sometimes taken a view which I don't agree with very well. He'll hold up a flower and say, "Look how beautiful it is," and I'll agree, I think. And he says, "You see, as I as an artist can see how beautiful this is, but you as a scientist, take this all apart and it becomes a dull thing." And I think that he's kind of nutty. First of all, the beauty that he sees is available to other people and to me too. I believe, although I may not be quite as refined as aesthetically as he is, that I can appreciate the beauty of the flower. At the same time, I see much more about the flower than he sees. I could imagine the cells in there, the complicated actions inside, which also have a beauty. I mean, it's not just beauty at this dimension of 1 centimeter. There's also beauty at a smaller dimensions. The inner structure, also the processes, the fact that the colors and the flower are evolved in order to attract insects to pollinate it is interesting. It means that insects can see the color. It adds a question. Does this aesthetic sense also exist in the lower forms? Why is it aesthetic? All kinds of interesting questions which the science knowledge only adds to the excitement, the mystery, and the awe of a flower. It only adds. I don't understand how it subtracts.
Right, and so for those that think the flower is ugly, the same thing happens. You can see the ugliness of the chemistry then. Okay, so some other examples of how these things that work supposedly only at some small scale and don't ever add up, just because usually they don't add up. Okay, the first one, how about this? Let's say you're building a bridge from San Francisco to Oakland, or maybe San Francisco to Honolulu. I would think you probably don't need to take into account the gravitation of Jupiter pulling on that bridge. I think probably if you worry about the ocean and the weather and the earthquakes, that you'll pretty much cover the tug of Jupiter on that bridge. However, and I'll leave this part as an exercise, you can plug in the mass of that bridge and the mass of Jupiter and the distance and find out how much force there should be on that bridge from the gravity of Jupiter. It exists. Just because you can ignore it, because you want to build something people can drive across and you've got to get your job done, doesn't mean it doesn't exist. Okay? Now here's another example. Different scales. Let's say there's a 1,000,001 people in a town, and 500,000 of them always vote yes on a particular kind of subject, and the other half always vote no. Okay. And you live in this town, so that means that your vote is the deciding vote. If you vote yes, then the whole million thing goes your way, and if you vote no, then it goes the no way. I guess it goes your way either way. So your vote is the deciding vote. Those other votes don't actually matter. Do they not exist? And what about this? What if you always vote, yes on that kind of subject? Then whose vote exactly is it that's the deciding vote? See, in the macroscopic scale, all that matters is the sum total end solution. You lose track of the individual because you can't characterize the individual. This is a beautiful thing about this physics, you see. It says in physics itself, you can't characterize the individual, even though you can make all these judgments about its relationships and things. Okay. So you can say who wins the election if there's 500,001 vote for yes and 500,000 for no. But you can't really answer which one was the deciding vote. So you see, you never can actually answer that. You lose that on the change of scale. So there is something fundamental about the change of scale in the patterns of reality. But it's not that it's not in the parts. All the components have to be in the parts, because insofar as that, what about the arrangements? Look, a thing's location in time-space is one of its properties. And an arrangement is just nothing but a set of locations in time-space relative to one another. So, it's a part of the physical properties. Okay, another one is relativity in Mercury. Relativity at the scales of non-relativistic velocities, like the orbital speeds of planets, relativity, it doesn't work at that scale. It shouldn't affect something as mundane as a planet, right, moving in the solar system. Okay, I'll make this one short because, of course, it does affect Mercury, and it explains an anomaly, what was an enigma in the orbit of Mercury for a while. You can look that one up. It has to do with the fact that Mercury is similar to the moon in that the moon's in like a locked orbit, right? It always faces the Earth, the tidal orbit. Well, Mercury's in a kind of a locked orbit, but it's not locked. It's just synchronized, and it flips over an odd number of times for an even number of rotations or something like this. And the reason is because the relativistic component adds up enough, it's whipping around enough, that even though it's certainly not moving like, wow, time would be different if you stood there, no, but enough for it to make a difference in the way the tidal forces synchronize, and it's gotten pushed into this little synchronous orbit with the relativistic issue going on. Okay, to move into actual quantum mechanics, what about this? Now, when you excite a hydrogen atom and then watch it glow, you see hydrogen lines. Particular, there's just a few of them in the optical range, and then there's more outside in other ranges, depending on how much energy is in the hydrogen atom. Okay, so there's a few of these that can be emitted, especially depending on where the hydrogen atom, what its temperature, its energy is, rather, sorry. So that's with one hydrogen atom. Okay, now in classical mechanics, if something has a certain energy associated with it, it'll glow in a black body. And because of quantum mechanics, it still fills up this black body, but there's dark bands where there's nothing. So the black body is like, there's spikes. The spikes are where the hydrogen atom is able to emit photons. Okay? So depending on the energy in there, the center of the little curve of what energy photons, it emits will move around. In other words, which is the most likely energy to emit photon to emit depends on the energy of the atom. And that's quantum mechanics. So instead of the black body thing. Now, if there is a cloud of gas the size of the solar system, let me see how much time I have. Oh, okay. If there's a cloud of gas the size of the solar system, guess what it emits, right? Because since classical mechanics is going to take over, it's going to emit this black body of electromagnetic radiation at all wavelengths, and just like classical mechanics says. But oh no, it's still the selected spikes, the lines. So maybe that's pretty big, size of the solar system, so that's kind of macroscopic. I have a couple no more.